today we're going to be working on how to work with quadratic functions given 3 points. Now 3 points means 3 ordered pairs. But before we start that, alright, does anybody remember the quadratic formula itself? Alright, go ahead and say it. You said x equals what? Plus or minus the square root. You said b squared minus 4 AC all over 2a. Okay. That's our quadratic formula. Does anybody remember what this part of the quadratic formula is called? It has a specific name, like that stuff that I highlighted in orange. It starts with a D. Oh, come on. Golly. You're right. It's the discriminant. All right. Discriminant. There we go. All right. So it says, Anna has heard the golden ratio is symbolized by the Greek letter phi. The positive value of phi is this. Okay? Now, this is approximately equal to 1.618. That's what that is approximately equal to. All right. Let's go to our graphing calculator. Show you how I got that, right? We're going to hit alpha y equals enter. We're going to do 1 plus the square root of 5 all over 2. We're going to press enter. And that's the golden ratio. That's the kind of the number. If you Googled it, so what's the golden ratio? That's what would pop up. Okay. So that's called phi. So right now it says, if this answer is obtained from working through the what? Quadratic formula, given the quadratic function in standard form, that will have zeros equal to the positive and negative of phi. So this is the positive value of phi. So we got to figure out which one of those. Now obviously, probably the easiest way would be just to type all these in and graph them and see which one hits where at 1.618. But let's look at this. Let's look at this formula. The discriminant happens to be what in this problem? What was the discriminant equal to? It was equal to a phi. So right now, automatically, I know my a value, my b value, and my c value. What number is in the denominator? 2. 2 times what is 2? 1. So I'm going to say my a value is 1. Okay. My b value. Well, that's going to be a little bit harder. Wait a second. It says negative b. That's a 1. What does b have to be? Negative 1. Because if you plug in a negative 1, it becomes a positive 1. So what's the only thing we have to worry about? We got to find our c value. So we have to do b squared minus 4ac, and that, we know what that's equal to. That's equal to a 5. So what did we say our b value was? Negative 1. Good. What did we say our a value was? 1. And so all we need to figure out is what? We need to figure out what would our c value have to be. So what is negative 1 times negative 1? That's a positive 1, right? Would you agree we would have to make this 1 plus a 4 to get us to a 5? 1 plus 4 has to get us to a 5. So what number would I have to plug in right there to make it go from a negative 4 to a positive 4? Negative 1. So what did we just find our c value? Negative 1. Now, do you guys remember what standard form is for a quadratic? ax squared plus bx plus c. So what did we find our a value to be? 1. What did we find our b value to be? Negative 1. And what did we find our c value to be? Negative 1. Which turns out our answer is c. That's how you would do it if you did not have the use of a graphing calculator. Okay? However, if you do have the use of a graphing calculator, you could use Desmos. We'll do it in Desmos. Alright, we'll just kind of get y equals, type in x squared minus x minus 1. Now, right here, see how it just pops up on the screen? What is that number right there? That was the what? 1 plus radical 5 all over a 2. You go back, remember we talked about what that was equal to? Right? So you could plot it right there. That's, you can use Desmos, plot it, and see where the 0 is, and that's the one that had the what? The positive value of 5. Alright, now what I want you guys to do is we're going to get our journals out, okay? And we're going to go through problem number 3 all together. This is going to be crazy, because we're going to take 3 ordered pairs, and we're going to find the quadratic function that goes through those 3 ordered pairs. Okay, so here's what I want you guys to do. First thing we're going to do for number 2 is we are going to write ax squared plus bx plus c. We're going to make a table. We're going to make an x and a y table. Now sometimes I might refer to y as f of x. Just remember, y is always a function of x, f of x is just function notation. So go ahead and jot that down. Right there, jot this down and jot this down. Alright, we look at problem number 2. It says, Abel considered the flight path of a model rocket as he thought. Okay, so rocket go up, rocket go down, right? That's basically what it should look like. Okay? He noted that after 2 seconds after launch, the rocket was 112 feet above the launch pad. So where it says 2 and 112, I want you guys to put 2 and 112. X is going to be your time, okay? The y is going to be your e, how high up it gets. We're getting another ordered pair to keep reading. It's going to be another ordered pair we're going to use. 3 and a 120. And what's the last one? 496. That's going to be pretty important. Now, what we're going to do is we're going to set ax squared plus bx plus c. We're going to set it equal to our y value, okay? So we're going to set this, so see how I just kind of rearranged it? We're going to put it in this order. So we're going to put a, I'm going to open up a parentheses, just kind of hang on with me here, and I think after we do this a bit, you'll understand what I'm doing. Okay? So just follow along to see if you understand what I'm doing. And then after we write this down, we'll go over the explanation to see if you guys figured out the pattern. Go ahead and write that down. I'm going to pause the video. You guys take a look at that and see if you guys recognize what I'm doing. Hopefully you guys notice that wherever I had a value for x, I plugged that number in. And then the corresponding y value I put there at the end. Okay. So each one of these, if I plugged in a what? Plugged in a 3 for x, I plugged it in here, and then I changed my y value to whatever the y value was every single time. Now what I need you to do is I need us to evaluate all of this real quick. I'll do one more real quick. I'll highlight this in colors. Oh, let's just change it over. All right. So right now, what is 2 squared? 2 times b. 4, so 4 in. 2 times b is 2b, and 1 times c is just c. And that equals what? 1, 12. Switch colors here. What do you guys think this next row right here is going to be? 9a, 3b. Okay. You want to take the last one, Judy? Four times 9. Oh, 16. Okay, good. There we go. Plus C equals 96. All right, now this is going to be pretty important now. to the matrix, okay? And go back to the matrix, okay? How many rows are we going to have? We're going to have 3 rows, and we're going to have 4 columns. Okay, we're going to make a matrix of 3 by 4. All right, so in our first row, you're going to write a 4, a 2, a 1, and 112. If you're wondering where I got the 1 from, since there's just one C, I use the number 1. The next row, I'm going to use a 9, a 3, a 1, and a 120. In the last row, you guys can probably see what I'm going to do. 16 and what? 4, then, good. So write that down. Once you guys have written that down, we need to go to our calculators and we need to build a matrix in our calculators. So we're going to go to our calculators. All right, now to get to the matrix, you got to hit the blue button and the X the negative one, that matrix button right there. And I want you guys to go over to the right where it says edit. I need you guys to edit and make it a 3 by 4. Okay? Luke, can you help me the number, the first row, help me the numbers that are going to go in there? Oh, 3 by 4, the very first row. Oh, second matrix. Go to the right where it says edit. You're going to edit matrix A. You're going to make it a 3 by 4. Okay. And now we're going to type in our numbers. Okay, so I think the first row is a 4, a 2, a 1, and 112. And the next row was a 9, a 3, a 1, and 120. And the last row was a 16, a 4, a 1, and a 96. Right? Just kind of go by memory. This is how you're going to build it. So I'm going to take a screenshot so you guys can. Very important that you build it as a 3 by 4. Now, we're going to let the calculator do what's called reduced row echelon form. Okay? We're not going to do it by hand. We're just going to let the calculator do it with use technology. All right? So you're going to, this is the tricky part. So if you need to know the steps, write down the steps as we do. Second matrix, we're going to go to the right where it says math. Second matrix, go to the right where it says math. But instead of going down, I want you to hit the up arrow until you find reduced row echelon form. Okay? Yeah, so here's the, see the math part? So after you get into the matrix, instead of editing, which we just edited, we're going to go to math. I want you to scroll. Instead of scrolling down, you can scroll down, but you can scroll up to reduced row echelon form. All right. Oh, you know what? I forgot to do my fingers. We have to hit second mode. We've got to get back to our regular screen. I'm sorry. It's okay. Go hit second mode, get back to your regular screen, then we'll do the same steps again. Here we go. Second matrix. Go to the right where it says math. Go up to where it says reduced row echelon form. And we're going to find the reduced row echelon form of matrix A. So we've got to hit second matrix and A. So that's what you need to see on your calculator screen. You're going to find the reduced row echelon form for A. And press enter. Now I'm going to help you guys interpret what this means. Okay? Everybody, this is your A value. This is the B value. This is the C value. So hold on. That's A. This is B. This is C. So I want you guys to write this answer down in your journal. Write that matrix down in your journal right now. All right, now that you've written that down, I want you guys to write y equals ax squared plus bx plus c. We're going to write y equals negative 16 x squared plus 88x. And that's it. Because what is our c value equal to? Our c value is equal to a 0. This is our function. It's our quadratic function. In physics, you'll come across this. You'll probably see this. You'll probably see like h of t equals negative 16 t squared plus like v, I think it's v subset o t, where that means the initial velocity. So I would write that down just so you know what we're going to need to know. Okay? So right now, based off of this, if I interpreted this, the initial velocity of the rocket is how fast? It's 88. Let's see what the word almost yeah, feet per second. Okay? So right now, it's 88 feet per second. That's the initial velocity of the rocket. So what I want you guys to do, after you write that down, hit y equals in your calculator. Type that in. Alright, you go with y equals, we're going to type in negative 16 x squared plus 88x. Let's check our table now. Oh, it's second window. Our first number, we started at 1, correct? Was that our first number or was it 2? Anyway. So, I need to do my table. Just my table, so just going up by points. There we go. Alright, so now look what we have. At 2 seconds, it's at what? 112. 3 seconds, it's at 120. 4 seconds, it's at 96. Does that match the original ordered pairs that we had? It does, doesn't it? Okay. So we found the correct. Now, if we wanted to see this, if you hit the graph button, you're going to notice that you really can't see where the graph goes. Okay? So what I want us to do is we're going to change our window settings. Okay? Go to your window. I want you guys to your window settings to go from 0. And I want you guys to go to 12. We're going to do an x scale of 2. For the y minimum, start at 0. For the y maximum, I would like you to go all the way up to 500. But do not count by 2s or 1s. I want you guys to count up by 50. Okay. So here's your window. This is what you would have to do in the graphing calculator to be able to see your graph. Okay. So right here, where's our maximum height? Right about there, right? Okay. Now, if I go to Desmos and do the same thing, okay, I can zoom out. And I can see the vertex pretty easily, right? How high did our rocket get? After 2.75 seconds, how high did it get? 121. Okay. If you look at the word problem, it said something interesting. It said, Abel's teacher asked him to use the domain and the range of the first rocket's flight path to predict the what? The domain and the range for the second rocket, whose initial velocity was what? Twice that of Abel's. What did we say the initial velocity was of the first one? First one, the initial velocity was 88. What's double that? Like 76. 176? Okay, here we go. Negative 16 x squared plus 176 x. Is that graph? Whoa! What happened there? Would you agree if you doubled the initial velocity, what happened to the height of the rocket? It flew a lot, not just double higher, it flew a lot higher. So how do we find this maximum point here on the graphing calculator? We have to hit second and trace. What are we going to calculate? Maximum. Now, remember we counted by 2s, right? 2, 4, 6, 8, 10, 12. So see how it's in blue? I got to go up to make sure I'm calculating the red one, not the blue one. We're going to calculate the red one's maximum height. Okay? So I'm going to say it's between a 2 and we'll just say 2, 4, 6, 8. It's definitely between a 2 and an 8. Did I have to use 2 and 8, or could I use the 4 and 6? Probably could use 4 and 6. What does it say our maximum height is in our graph calculator? At 5.5 seconds, it's 44. So in our graph, what I want you guys to do, I want you guys to understand, it started at what, 0 and went all the way over to an 11. How did I know that it ended up at 11? Because what does that 5.5 represent? Do you remember what this line is called? It has a specific name. That's right, that's the axis of symmetry. And the axis of symmetry always splits a parabola perfectly down the middle. What's this point called, just as review? That's the vertex, you're right. In this particular case, it's what's known as our maximum. Okay? So on this problem, if you just kind of drew a sketch in your journal, it doesn't have to be that big. Just say, that was the sketch. Okay? What was our maximum? Is that a 5? What was our maximum height? At 5.5, it reached all the way up to what? 484. Okay? So if it says, what's our domain? Our domain started at 0, and it went all the way to an 11. But what was our range of our problem? The lowest height was 0, but it went all the way up to what? 484 feet. So that's the domain. The domain, remember, goes from how far does it go on the x values? Where did it start? It started at 0. Where did it finish? It finished at an 11. The range, where did it start? At 0, and it got all the way up to 484. That's why the answer in this particular case is H. Okay? But we did this in our journal for showing you how to do things step by step. Why is the answer H? Because we had to find the one that did what? After its velocity was twice. What was the original problem? The original problem, what was our maximum height? It was at what, 2.75 and 121. That was our original one. Okay? But our final problem was Alright, number 3 is actually a lot easier of a problem. Okay? Number 3, hopefully you guys, now that we've done reduced row echelon form, hopefully the answers to number 3 will kind of make sense now. Like one of these is the right answer. Okay? So here's what I want us to do. I want us to first make a table. Okay? Make an X and a Y table. And it says it has roots. Uh-oh. Now we got to know what the word root means. What does the word root? What do you guys think? I didn't hear you. X-intercept, that's right, x-intercept, also known as solutions or zeros, okay? So we actually, if it tells us that we have a root at negative 2.5, then it's at negative 2.5, 0. And the other root's going to be at 1, 0. And the final ordered pair is what? Negative 3 and 4. So those are our ordered pairs. So here's what I'd like you guys to do right now. On your own, this is what I'd like you to do. So I'd like you guys to take ax squared plus bx plus c, set it equal to y. Okay? Take all of your y values, all these y values, where are you going to put them? Right there at the end. And what are you going to do with all of these x values right here? What are you going to do with them? You're going to simply do what? Plug them in. So you're going to have 3 rows. So I'm going to I'll set it up, and then I want you guys to come up with the final answer. All right, here we go. A parentheses squared plus b parentheses plus c equals 0. Second one. I'm going to say also equals 0. But what's the last one going to equal? That's right. Okay. All right. predict what number am I going to plug in the first row. Jacob, what's the first number I'm going to plug in here and here? That's right, negative 2.5. So put negative 2.5 there and put negative 2.5 there. All right. Say you were, where am I going to plug in my second row for my x value? These are all my x values. First one I plugged in what? Negative 2.5 second. That's right, 1 and a 1. Base, third one. Third one. That's okay. Got it. Negative 3 and a negative 3. Notice, I'm plugging all of my x values in for x, and I'm only plugging in my y values where there's a y. How many x values are you having to plug in here? A couple of them, right? One that's being squared, one that's not. So what I want you guys to do is I want you guys to come up with one of these answers. Okay? Does anybody feel comfortable telling me what they got right here for the first one? What's negative 2.5 times negative 2.5? Positive 6.25a. All right? That becomes a negative 2.5 b plus c equals 0. This one should be pretty easy, right? Just 1a plus 1b plus 1c equals 0. Negative times negative is a 9a minus 3b plus 1c equals 4. So I'm going to highlight what you need to interpret. This is this right here, and this right here, and what do we need to build? Be able to build with it? Build a matrix. Okay. So what's our first row going to be? 6.25, negative 2.5, 1, and 0. Second row, what does it look like? 1, 1, 1, 0. Third row. Negative 3, 1 and 4. We just got to find the one that matches every single one. Does that match every single one? Yeah. That's the answer to what. Now, that's how you do it in reduced row echelon form. Okay? All right? And then we would use that to find what? The A, B, and C. Okay? Now, I'm going to see if there's a, we're going to try another method here real quick. Okay? This will be the last thing we do today. I want you guys to hit stat, edit, and I want us to type in our roots. One of them was what? What are our roots for that problem? Was it a 1? Or are 3 roots? Look at that. Oh wait, negative 2.50. Okay, so I'm going to hit stat, edit, type in negative 2.5. Not 2.25. 2.5. And then that was a 0. And then we had a 1 and a 0. And then we had a negative 3 and 4. Alright. So this is these are L1, that's your x values, those are your y values. Okay? And we're going to hit stat, right arrow. I want you guys to go down to not number 4, number 5. See where it says quadratic? That means the regression for a quadratic equation. Press enter. Go all the way down to where it says store regression equation. And this is how you store in your calculator. Hit alpha trace, enter. Alpha trace, enter, gets you that y1 right there. We're going to store it. We're going to calculate it. Cool. What does it say our A value is equal to? 2. B value is a 3. C value is a 5. So what would our quadratic equation be? Or function be? 2x squared plus 3x minus 5. That's a lot faster. to solve it quickly that way. But if I needed to do it reduced row echelon form, I had to show you guys how to use reduced row echelon form to be able to do that. Okay? So, in Desmos, this is what you have to do in Desmos. So just follow along if you go, please. Okay? What we're going to do is we're going to do this. We're going to hit Y1 squiggly line, A, X, I know what I have to do. I'm going to go back. This is where you have to write this down. It's going to be hard to remember everything that I'm going to do here. But just by watching, you might be better. Close the parentheses, square, plus B, X1, plus C. Put that through. C. I'll have to go back there. Okay. So right now, you guys see that right there? Write that down, because that shows you how to use Desmos to do it. That doesn't make a whole lot of sense right there, but I'm going to go ahead and make a table real quick. Plus, I'm going to make a table, and I got to change this. Unfortunately, I got to change this to a 1 and 1. This only works if you use X1 and Y. I'm going to use the same ordered pairs. We're negative 2.5 and a 0. The next one was it 1 and 0? 1 and 0. Okay. And then a what? Negative 3 and 4. Hold on. Now, I'm going to pause it right here. I want you guys to take a look at this. Look, what does it tell us? It tells us our A value, our B value, and our C value using what? 3 ordered pairs. But in Desmos, this is how you would have to do it. So how many different ways do we find using 3 ordered pairs? Reduced row echelon form, using the quadratic regression, and also using Desmos. Okay, so those are the 3 different ways that you can do it.